Let us now solve 41st question of GATE 2018. A continuous and aligned carbon fiber composite consists of 25 volume percentage of fibers in an epoxy matrix. The Young's modulus of fiber and matrix respectively are 250 gigapascals and 2.5 gigapascals. If the composite is subjected to longitudinal loading, isostrain condition and assuming elastic response, the fraction of load borne by the reinforcement has to be found out. So let us solve this problem. So let us write down the data. It is given that the volume percentage of fibers is 25 volume percentage. That is Vf is equal to 0.25, from which we can find the volume fraction of matrix, which is 1 minus 0.25, which will be equal to 0.75. The elastic modulus of fiber is given as 250 GPa and the elastic modulus of matrix is given as 2.5 GPa. We have to find the fraction of load that is borne by the fiber reinforcement, that is Pf by Pc, where Pc is the load of the composite and Pf is the load borne by the fiber. Also it is provided isostrain condition, which means that the strain is uniform throughout. That is, the strain on the fiber will be equal to the strain on the matrix and the strain on the composite. So the fraction of load borne by the fiber reinforcement can be written as Pf by Pm plus Pf, where Pf is the load given to the fiber and Pm is the load given to the matrix. As we know, the load is equal to the stress multiplied by area. This equation can be written as sigma f AF divided by sigma m AM plus sigma f AF. Also we know that the elastic modulus E is equal to the stress by strain. So this equation can be further written as the elastic modulus of the fiber multiplied by the strain of the fiber and the area of the fiber divided by since it is asked to assume isostrain condition, all the strains are equal, so this strain value can be cancelled out from this equation. This will be equal to EF AF divided by EM AM plus EF AF. As we know that the area of the fiber will be equal to the volume fraction of the fiber multiplied by the area of the composite. Similarly, the area of the matrix will be equal to the volume fraction of the matrix multiplied by the total area, that is the area of the composite. So on substituting these values, we will be getting the fraction of load as EF VF AC by EM VM AC plus EF VF AC. So this area of the composite term can also be neglected. So the final equation will be EF VF by EM VM plus EF multiplied by VF. As we know all these values, let us substitute these values. 250 multiplied by 0.25 divided by 2.5 multiplied by 0.75 plus 250 multiplied by 0.25, which on further equating gives 62.5 divided by 1.875 plus 62.5, and the final answer will be 0.970. So rounding off to two decimal places, the fraction of load borne by the reinforcement will be 0.97. This is the answer.